Welcome to the second part of the Introduction to Eco-Design of the training session of the G.EN.ESI project. Within the first part of Module A, you have been introduced to life cycle thinking and importance of this concept for eco-design of a product. Part 2 of this module will focus on the assessment of the impact a product can have on the environment during its life cycle. Module B will provide you with practical information on how to model the different phases of product life cycle during its design. This web seminar has been developed within the framework of the G.EN.ESI project, which aims to support the integration of eco-design within the design and development process by developing a methodology and a platform. The methodology is presented in Module C and the platform and software tools in Module D of this training. This research project started in 2012 and involved 8 partners, 3 from academia, the University of Bath, University Politecnica del Marche, and Grenoble INP, 1 public institution, G.EN.ESI, which is the National Agency for New Technology, Energy and Sustainable Economic Development, and 4 industrial partners, Grant Design, Sibu Environnement, Faber, and Bongli-Fleol-Electron. It is co-financed by the European Commission. So, what are we assessing exactly during an environmental assessment? We are evaluating the impact an activity has on the environment. As defined by the ISO 40001 standard, an environmental impact is a change, positive or negative, on the environment due to the realization of an activity. This impact is measured using environmental indicators. One example of such an indicator is raw material depletion, that represents the extent to which an activity requires resources, materials or fuel, to be realized. There are different types of environmental indicators, and further details on environmental indicators are provided in Module B, Part 1. One of the most common indicators is global warming. It represents the emission of CO2 and other gases into the atmosphere and has a variety of long-term effects such as loss of biodiversity or modification of marine currents. Ozone depletion is another environmental impact that is responsible for the disappearance of part of the ozone layer on the Earth's poles. Raw material depletion is an environmental indicator that has consequences on the availability of resources for future generation and the price of the material. Environmental impacts have varying time and geographic scale. Some are local, like spills of chemical from an accident that affect the zone where the spillage occurred. Others are global, like global warming, where the emissions of green gases anywhere in the world modify the climate globally. Global warming also represents a long-term impact. Emissions generated today are going to have an effect on the environment in maybe hundreds of years. At the other end of the scale, emissions responsible for odors are short-term environmental impacts. Once the emission has stopped, they dissolve in the air and cease to be an inconvenience. For eco-design, evaluating these environmental indicators over the product life cycle is crucial. It is crucial because environmental assessment is about evaluating all the impact generated over the product life cycle in order to make a decision on whether or not a design solution is an improvement for the environment. In the case of electric car, if we look at the raw material depletion during the first phase of a product life cycle, it is worse than the conventional car because a lot of raw material are needed to manufacture the battery and the electronic controllers. But on the other hand, depending on the electric mix used for recharging the battery, it emits very little CO2. By looking at the product life cycle and at different types of environmental indicators, we can make an informed decision about whether or not the electric car is better for the environment. Life cycle assessment, LCA, allows for a complete evaluation of product environmental impact by considering multiple impact categories to illustrate a range of environmental damage for every life cycle phase of a product. It is the most common approach used in eco-design because it prevents impact transfer. The multi-indicator and multi-phase assessment provide designers with a bigger picture on environmental issues, preventing them from implementing solutions that are, in the end, detrimental to the environment. Module A provided you the two basic notions behind eco-design: life cycle thinking and environmental assessment. Module B will provide you with the information on how to model product life cycle in order to evaluate its impact on the environment, following the recommendation of life cycle assessment.